In this lesson, we're going to learn how to simplify radicals using kind of a cheesy method I created called Prison Break, but it will help you remember how to do it. So using your imagination, I want you to picture something that's real in the math world. And in this example, we have this number out here is called the index, and it's usually written small and kind of inside the V of the root symbol. Then this number underneath here is called the radicand, and then the actual symbol is called the radical sign. And so how we're going to use our imagination is this. We're going to let the index represent the level of security of our prison. The radical sign is going to represent prison walls, and so anything that's inside the radical sign is going to be prisoners. So how we're going to use this prison break idea will be shown in example 1. Example 1, it may look a little more complicated than one that you will have right away, but we're going to use this example, and if you can do one like this, you'll get the concept and you'll be able to use it on any level of problem. So square roots are a low security prison. And so in other words, these are not so bad guys that are in this kind of prison. Maybe they didn't do as bad of a crime. And so what we have, the example in math will look like simplify this square root with 24x to the 5th and y to the 4th inside the square root. Now you may not know this, or you may already know this, that when you have a square root, there's an understood index right there. And that understood index is a 2. And we will have more complicated indices like 3 and 4, and that's a cube root and a 4th root. But square root is the most common one, and so they eventually just quit writing the 2, and it's understood to be a 2. And that's going to be important when we get to ones that have a 3 and a 4 and a 5 there, and you'll understand. So square roots have an understood index of 2, and so what that means in my prison break example is pairs are needed to be able to prison break. We need 2 of something to be able to prison break. So the first thing you want to do is put this thing into its what we call prime factorization. You may have done a factor tree before. I'm going to do a factor tree off to the side and say, let's just deal with the number first. 24, you want to factor it into 2 factors that equal 24, and you can choose any 2 factors you want. You could choose 2 and 12, or 4 and 6, or 8 and 3. There's lots of choices. I'm going to choose 4 and 6. It really doesn't matter because we'll all get the same answer in the end. And then if each of those factors could be factored again, in other words, there's more factors to these, you'll go ahead and factor further. And 6 can be factored to 2 times 3. And then each of these, 2, the only factors it has is 2 times 1, and when a number has factors of only 1 in itself, it's considered prime. So as soon as you get a prime number, you can circle it, whether it's on this step or the previous step or the next step. And these are all our prime numbers, and so that's called the prime factorization. You've probably learned that already. And then with x to the 5th, you have basically just 5 x's times each other, and y to the 4th you have 4 y's multiplied by each other. So we're going to put this into its prime factorization form. So here you can see we put the 24 prime factorization, the 5 x's expanded out, and the 4 y's expanded out. Now that we have it expanded out, we need to think of the prison break analogy. Picture these all as different prisoners that are inside this prison. And every prisoner needs a buddy to help him escape from prison. And so he needs somebody to distract the guard or whatever he needs, but there needs to be 2 people working together to escape from prison. So what we want to do is circle all the pairs that look alike. So these are the guys that are going to work together to try to escape from prison. So here's where you use your imagination. I rewrote all those things, kind of paired them up in colors, and they're going to make a run for it and try to escape from prison. So the first pair makes a run for it, but the prison guard comes after him and shoots one of them, where the other one makes it out here alive outside of prison. So only one of the two actually escaped. The other one disappeared because he got shot and died. It's kind of a morbid example, I know. So the next ones that are going to try to escape are these blue X's. The blue X's make a run for it, and there's the guard again. And one of our guys makes it out here outside of prison. He makes it out alive, and this one you can see him disappearing. He's about to die. Now the green ones make a run for it. And one makes it out alive, but the other one gets shot by the guard. And the yellow Ys make a run for it. And once again, one of them makes it out alive, and the other one is going to be shot. And the purple ones make a run for it. Maybe they'll be the pair that makes it out. Could it be? No such luck. So, now that the prison break is over, let's see what we've got left. We have got a bunch of things out here that made it out alive, a bunch of guys out here. And so I wrote them over outside of our radical as free guys. I called them free guys because they're free now. Then I've got 3 guys that were left inside because they didn't have a buddy to help them escape from prison, so they're going to stay in prison under the radical sign. And we're calling those prisoners still. And then the dead guys, the guys that got shot, disappeared, and so they're gone. They're just gone and buried. So if you multiply what we have on the outside, we get this simplified. And if we multiply what's on the inside separately, we get this on the inside, and that is called our simplified radical. So this square root at the very beginning simplifies to this square root at the end. So that's square roots, but what about roots with indices higher than 2? These would be considered higher security prisons. So maybe they did worse crimes. So a 3rd level security prison is a cube root, and this is just a different kind of prison. What's under there are still prisoners, but the type of prison that it is a higher level security prison. So we've got to do something a little different. Since it's a higher security level prison, you need 3 friends that have to work together to escape, because there's more guards, there's more security, and so they're going to have to work a little harder to be distractions and get out of prison. But still, only 1 out of each group survives, and you'll see why in a minute. So in this one, you see that it's a 4th root, and a 4th root is a 4th level security prison, and so 4 friends are going to have to work together. These are getting to be the really, really bad guys. And then we're going to go all the way up to a 5th level security prison or a 5th root, and they are going to need 5 friends. I think you start to get the idea. But even still, with 5 friends, only 1 is going to make it out of each group. And so they're really taking a risk by running out of prison at security level 5, because only 1 out of each group is going to survive. So example 2 is going to be a cube root, which is a 3rd security level prison. You need 3 to work together to escape, but only 1's going to make it alive out of each group. If we broke it down into its prime factorization, this is what we would have as far as prisoners. Since this is a 3rd level prison, we need to circle groups of 3 that look alike. Only groups of 3. Now we're going to do our animation again. The first group of 2s makes a run for it, and we've got 1 that was really fast and he got out of here really fast. We've got 2 that are still trying to run, but our security has a higher powered weapon and is able to kill 2 guys with 1 shot. So now the 3 green X's are going to make a run for it. The first green X makes it out quickly again, and this green X doesn't look like he has much hope. This green X might be able to run the other way and maybe escape. However, in this higher level security prison, there are more guards, and this is the guard's twin brother. He works there too, and he's going to get this other guy from the other side. And the orange guys make a run for it. And let's see what happens. They don't look like they have much chance. And they're gone, except for the one that made it out here alive. So we gather up all the remnants and see what we have left. We have these 3 guys that escaped. Those are our free guys that sit outside of the prison. Then we've got our 3, 3, and X out here under the radicals, still in prison. These are our prisoners. And our dead guys are gone. Those were the guys that got shot and disappeared. So here we have our simplified radical by multiplying the things that we had on the outside separately and multiplying the things that we had on the inside separately, and that is our simplified radical. So I imagine you're getting the idea, but one thing I wanted to do was not only do a 4th level security prison, but also have some numbers and letters outside of the radical already. Sometimes they'll have some numbers inside and some numbers outside at the very beginning of the problem. So what that means is that these guys were just already free. They never were in prison maybe. And they're out here waiting for their friends to try to escape from prison, and they're going to help them out. So these guys were already free, so they don't go anywhere except the place where they already were. Since this was a level 4 prison, we need groups of 4 to try to escape, and out of that group, only 1 makes it out alive. Then this group makes a run for it, and out of that group, only 1 makes it out alive. The others disappear, so you don't account for them anywhere in the picture. And then we look at who's left. So you can see here in blue, we had a 2 that was still in prison, an X, a Y, and a Y. And so when we multiply these, don't forget about the free guys that were already out there. And then these free guys came and joined them. So all together we multiply that as a bunch of free guys, and we get 10x to the second. Don't forget to put your index. If it was a 4th root, it needs to stay a 4th root. The prison doesn't change types. It stays a 4th level prison. And then these are the prisoners that are left inside, which is just a simplification of all these prisoners. So the last thing we need to talk about is what happens when all the prisoners are gone. Well, then you wouldn't need a prison, and the prison would close down. So our last example will illustrate that. In this example, we have an X that's already outside the prison, and we had 5 guys inside a 5th level security prison. These are the really bad guys. So they need a group of 5 to be able to escape, and they have their group of 5. But when they make a run for it, only 1 makes it out alive. The others get shot and are buried. And so we only have the 1 X that makes it out alive. This other X came from the X that was already sitting outside prison waiting for his buddies to try to escape. And so these 2 guys are free guys, and there's nobody left in the prison. So what happens? The prison closes down. So our final answer is just x times x, which is x squared, and that is a simplified version of the original problem. Hopefully my prison break video will help you understand radicals for the rest of your life. And to practice this, I would do a few examples from the prison break practice worksheet that I've made on my website, www.susiethetutor.com. Look under videos, radical expressions, and then find the prison break worksheet. Have a great day.